Hello everyone. Welcome to this tutorial on Slurm job submission. So this is something which we normally do in computing clusters, which are available in high performance computing clusters basically. So Slurm means simple Linux utility for resource management. So what is Slurm scheduling? Let's try to understand that first. So basically, when you are doing a corporate job or you have, or maybe you are part of a university, so everyone uses a single cluster, a single computing cluster, and everyone submits their code for running them. So if a lot of codes are submitted by a lot of people, now some kind of scheduling has to be done because there is limited resource available in the computing cluster. So which code gets to run fast and which code gets to run next and next and next. This scheduling has to be done by someone and it cannot be done manually, obviously. So this whole resource management on which code runs first and which code runs last and the entire sequence of code running is actually determined by Slurm scheduling. So not everyone has access to computing clusters. If you have access to normal servers or maybe AWS servers, then you cannot really run Slurm jobs, right? Then in that case, your best bet is to use Screen. So Screen is something which you can actually use to run multiple codes together in parallel at the back end. So the whole process is actually shown in this tutorial. I mean, if you follow this, you should be able to, grasp the whole concept of how Screen can be used. And Screen can be used in computing clusters as well, but like it's much less powerful and you cannot really run your jobs for a long time because there are limitation stuff. So it's best to submit jobs if you are working on HPC clusters. So first of all, let's talk about login node. So the moment you log in to your cluster, you will see something like this. So you can see that here it's login, right? It's a login node. So first of all, login node, this is something which you shouldn't be using for running your compute resource heavy codes because this node is only for logging in and to do basic file operations and stuff. And you just have to submit your jobs when you log in to a login node. So basically from your login node, you can submit jobs for running them in the computing nodes, but you shouldn't run codes directly in the login node. Say, I shouldn't be doing like this, right? I shouldn't run my Python script in the login node. That's what I'm trying to say. If you do that, then what happens is it becomes slow. And then, all the people in your corporation are actually accessing the login node. So their operations, day-to-day operations become very lengthy because now the whole system is actually very slow. So now let's go to interactive node. So I'm going to show you how to open an interactive node first. So interactive node is one kind of computing node. So if you use an interactive node, then you can run codes like normal. Like normally you can run code on the real time. You can run things, and it's a computing node. So there isn't any constraint like login node. You can run any code you like, no matter how resource heavy it is. Let me explain the command first. So first of all, you have this thing. So that means this interactive node is going to run for 8 hours maximum, and different institutions have different time limit here. So you cannot really specify any time limit, right? You cannot say that I will run it for 3 days. Probably you cannot do that. In my institution, it is 8 hours, but maybe in your institution, it's something else. Then this is n tasks per node. So maximum you can run 4 tasks together parallelly here. Then there is the memory limit. It's set to 15 GB. You can like increase it or decrease it, but again, there is a limit according to your institution. Then this is an interactive node, and then this whole node is going to run in the terminal, the bash, right? Okay, so let me run this first just to show you what I mean. So if I run this command right here and I press enter, so you can see that currently I am in the COM112. So COM112 is the computing node number 112, that is the interactive node in my institution. So I can run any code I want right here. You can run some code, like you can run anything right here as you wish. Now, first of all, I want to mention why we use interactive node. So obviously, when you submit a job, so here we are not submitting a job, we are just running an interactive node. So if you submit a job, then that job will take some time to run. Okay, that job will not start running from the very moment you submit. It can take even 1 day or 2 days to start running because of the scheduling process, right? So if you're debugging your code, if you're debugging your entire system, that is not something you want to do. You want to look at the errors. You can do trial. You want to do trial and error on the fly, in the real time. That is why you want to do those in the interactive node. Just develop your system. You just keep running your code. You just find the errors and you keep doing that until you have finalized the whole system, right? That is basically interactive node for you. Now, obviously, this is an interactive node, and let's see one thing. Let's look at this command sq. So if we write sq, then all of the user sessions or user jobs or interactive nodes will be shown here. This is, I think, not what we want. What we want is we want to do sq grep our username. So just type in your username right here. Okay. So let's type in my username. Okay. So then, as you can see right here, there is a job ID at the very left. Then there is the interactive name. Then there is my username, and then there is like it's running for 1 minute 43 seconds so far. Okay. So I don't want to stay here in the interactive node now. I want to quit this job. So the command for that is cancel, and I will copy paste this job ID. And yeah, that's it. So I am out of the interactive node right now, right? That is as simple as that. There is nothing complicated here. So if I now again type in sq, let me type in again sq grep Rahman's here. You can see there is nothing because I am not running any jobs at the moment. Okay, fine. That is the interactive node, very simple. Now let's move on to another thing. Let's move on to job submission. So now we're coming to the actual job submission. So before you submit your job, the first thing you need to do is you need to activate your virtual environment. So maybe the code you are trying to run requires certain environment for it to run properly. So you need to activate those first. So for example, here let me just activate one of my virtual environment named BioPython. So I've activated this right now. As you can see, I've activated it. So I mean, I'm using Mamba in my system. You can use Conda because Conda is the most popular one. So you can do Conda activate your virtual environment name. So I have everything now available here in my own virtual environment. Now, there are other things. I also want to mention a few other things. Maybe there are some libraries which are not there in your virtual environment, but you need those for running your code, right? Okay. So first of all, suppose there is this package called PWA, right? There is this package called PWA, which people use to align genomes, which people use to align like first reference genomes and other stuff. That's not important. So if we want to see what version of PWA is available in our system, like what version of a particular library is available in our system, we can simply write module spider BWA. So BWA is the one I'm interested in. So if I write that, so you can see the version number and everything has appeared here. Now, if I want to load this BWA in my system, I can just write this command. So let me just write this in here and let me type. Okay. Now, if I write module list, you can see that the currently loaded module is BWA and this one. So I have this BWA module loaded in my system. So basically currently in my system, I have the virtual environment BioPython. Let me just zoom this in actually. I have my virtual environment BioPython and I have the BWA library loaded also. So I have two things loaded together. Okay, very good. Now let me clear this thing up. So now I can submit jobs. I can submit jobs through which I will be running codes. So I have covered these things. So now let's look at this. So let me actually show you an example. Let me go here. So here you can see multiple files, right? Test1, test2, etc. So I'm going to explain exactly what are there in these files. But before that, let me go here. Let me first run test1.sh. Okay. So I have run one job. I've submitted one job. Let me also submit the second job. I have submitted the second job. Fine. So I have submitted two jobs. That means I'm trying to run two codes. What is inside the file? I'm going to explain it later on. So now let's see the list of jobs I have submitted. SQ, Grape, Rahman Siyar, like I did before. So let's actually go in and see what's going on here. So you can see that there are two jobs here, right? And the job IDs are in the left, 1681930 and other things. And also you can see that these jobs are actually running. So how did I understand that the jobs are running? There is this R, you can see, right? There is this R for both of the jobs, and they have been running for 15 seconds and 19 seconds respectively. Right here you can see, right? That's very simple. Now this R will not always be there. Sometimes, let me just zoom out. Sometimes what will happen is instead of this R, you can see something like PD. PD means pending. That means it's still not going to run. So up until you actually have R right here, your jobs are not running. That is the very important thing. Your jobs are not running up until you see R right here. You have to wait. Sometimes you have to wait for a long time as well. Okay. So let me show you one more thing. So you can see that currently it is 1 minute 20 seconds. See, so the job is running. So I don't want to run this job, so I will just cancel this two. So I will just cancel this one, yeah, and I will just cancel 1929 as well, 1929. Okay, fine. Now let me again check. Okay, see, there is no more job, right? The jobs are cancelled. Okay, fine. So now you know how to submit jobs. You can submit 5, 6, 7, 10, how many ever jobs you want. You can submit those. Now let's look at the actual script, right? Let's look at actual script, like what is the meaning of the script and how to write a JavaScript. So there are two kinds of script mainly. One is a JavaScript without any argument. So let me zoom in a little bit. So you can see that the extension of the file is .sbatch. So this file will be .sbatch type. That is the important thing to understand here. The name can be anything, but the extension has to be .sbatch. So let me open up a .sbatch file right here and let me walk you through the whole thing. So first of all, you can see here that this just tells the computing cluster that, okay, this is a bash file and I need to run this using bash. And then you have the job name. This is the job name. Mamba job is the job name. Then you have the time. So how much time the job needs to run maximum. So suppose the code that I'm trying to run is here. So I'm trying to run this Python script using this job submission. Suppose this script runs for only 10 hours. Only 10 hours. In that case, the job will end after 10 hours. That is as simple as that. But suppose this script is trying to run for, let's say, 60 hours. In that case, there will be some issue. After 48 hours, the job will actually quit automatically. That is the issue. Okay. So this will run up until 48 hours. N1 means only one node will be used. Node is basically a virtual or a real computer. So only one computing node is being used here. One task will be run at a time. There will be 48 CPU cores, which is a lot, 48 CPU cores. And per CPU core, we are going to allocate 3.5 GB of memory. This is a megabyte, by the way. This 3500, this is megabyte. So per CPU, there is 3.5 GB memory allocated. So total RAM is 48 into 3.5, which is quite a lot, right? So depending on what kind of computing cluster you are using, you can or cannot specify certain configurations. Then finally, we have these two things. You can see here output and error. So let me explain these two things first. So let me actually show an example. I think that will be better right here. So you can see that there are two files. Let me zoom in again. You can see there are two files right here. Mamba job dash some id.air and mamba job dash some id.out. Okay, fine. So what are actually these two things? Let me explain this. So after running your job, after your job run is over, there can be error, right? When you run the code, there can be error, maybe, and there also can be some warning messages. So those errors and warning messages will appear right here. So for example, this is a very large file. There are many warnings and other things here. An out file will have mainly your print statements. So in your code, if you have some print statements, or you have some output that you want to display in the screen, those will actually appear right here. So I mean, I have actually output all the file names that I am processing here. So those are appearing here. So how do we specify their names? How do we specify their names? So that is what I will mention now. So you can see here again that the output file name will be percentage %x. That means percentage %x will be replaced by the name. So any name can be given here. You can give any name here. That name will appear here. So this name will be Mamba job, and percentage %j will be the ID. So before you saw that when I submitted the job, there is some job ID. So that job ID will appear right here. So that will be how the files will be named. Okay. And finally, this is very important. This means what kind of queue you will be using, right? So there can be many kinds of queues. So let me explain the queues. Okay. Let me go here again. So there can be, let me zoom in a little bit. There can be mainly 3 queues, but obviously if you have GPU access in your cluster, then there can be more than 3. There can be other queues as well. You need to contact the competent cluster administrator to know about those queue names as well. So in the express queue, as you can see right here, if you run the code for only 1 hour or less, right? So before we specified 48 hours, if you run for only 1 hour or less, then it is going to be put in the express queue. So you need to mention express queue. If you are running more than 1 hour but less than 3 days, that means 72 hours, then you should put it in the normal queue. And if you are actually running for more than 3 days, up to 14 days, like 2 weeks, then it is going to be long queue. You need to specify long. Remember that it is very important to specify this properly. This is because if you specify express queue, then your job submission will be prioritized, because then the Slurm job scheduler will understand that this job will not require that much time, so let's put it forward and let's get done with this. And if you make it long, then the competent cluster will say, okay, let me actually get rid of some jobs first, let me finish some jobs before, and when I will be free enough, then I will run the long queue. That means your job will not be prioritized, it will be scheduled late, right? So that is very important, right? Okay, so now that you understand this is very important to understand that you need to put the minimum time here, like as less time as possible. You need to put as low queue type as possible, like express queue, if that is convenient for you. And the resources you need to make as low as possible according to your requirement. Because if you have low resource, low runtime, etc., then your job will be prioritized, right? But obviously, if your code requires more runtime, more resources, you need to specify that accordingly, right here. Finally, you have this particular thing, you have this particular command. So this is just the command for running your script. So I'm running a Python script here. You can run any script right here according to your requirement. Okay, so that is basically the bash, the JavaScript. And I've already shown you how to run it. You just run it using this command right here, sbash. Let me just zoom in here. So sbash, then run underscore test.sbash or anything like that. So what I showed you just now is actually a job script without any arguments, but you may have arguments as well, right? You may have command line arguments. So how do you do that? Another thing is this entire GitHub repository containing instructions and these scripts are already provided in the GitHub. The GitHub link is there in the description. So I will share that in the description. So make sure to check that out. Okay, now move on to this one, which has the arguments. Sometimes your Python script may require some argument, right? Some command line argument. It can be 1 argument, 2 argument, 3 argument, whatever it is, you can do that. So how exactly are you going to do that? It is very important to understand that one way to do this is to directly put the argument. Say here the argument is train, suppose, right? So we just directly put it right here. But if you don't want to manually put this here, and you want to put the argument in the sbash command itself, then you need to specify those right here. You can specify runtime equal $1, maybe what should I say, eStrain equal to $2, etc. So if you want to give another argument here, you can just add is train right here. That's it. That is entirely it. You don't have to do anything else. That is very simple. Okay, fine. Now, let me also show an example of how to run such scripts, right? Let me go to an example path right here to show you what I mean. Okay, so here, I think I have some, yeah, I have this argument right here. So let me run this one, okay? Run dilution. Let me go here first. So sbatch run dilution. Now I want to give an argument here. That argument is suppose string, okay? That is it. That is how you want to do this. And I want to check here. Okay, it's running again. So I don't know. I'm very lucky today. Everything is running properly without any waiting time. So I want to cancel this right now. I want to cancel this whole thing. So, okay, cancelled. I hope that it's cancelled. Okay, fine. So this is the whole thing about how you can run everything. So I have pretty much covered everything. I have pretty much covered everything that you need to know about Slurm and about computing clusters. So hopefully you can do well with these things and see you in the next tutorial. Thanks very much.